Welcome to the Walton Pie. Today I'm going to go over several of the different problems that I included on one of the exams that I recently gave. I'm going to go through and walk through the steps to be able to get to the correct solutions. For each of these problems, feel free to pause the video right before I go through the steps just to try it on yourself and then follow through with my solution to be able to see where maybe you have some things that you're like, hey, I'm not 100% sure on this, so that you can be able to focus on that. So the very first problem that was on my most recent exam was to solve these inequalities and then write our answer in interval notation. And then I'm going to keep almost all of my stuff in fractions, but if you did want to put everything into decimal places, you would be able to rewrite it and put it into decimals. So for this first problem, we have x minus 4 times x plus 5 is less than x minus 3 squared. So the first thing to do with this is to expand it, to try and get something so that everything is in a situation where you can be able to solve this. So I'm first going to expand out both sides. I need a better pen. So the first thing we are going to do is expand out both sides. So we have, on this side, we have x minus 4 times x plus 5. And on the other side, we have that this is less than x minus 3 squared, which is x minus 3 times x minus 3. So once we have this, we are going to FOIL on both sides. We're going to distribute. So on this side, we get x squared plus 5x minus 4x minus 20. So I did the front terms, outer terms, inner terms, and then the last terms to get this. And on this side, I get the same thing. I get x squared minus 3x plus 9. And then I'm going to try and simplify this. I am going to try and get just an x on one side and everything else to the other side. So I'm going to start by subtracting x squared from both sides. And then these combine to be a plus x. So we have plus x minus 20. And then we have a minus 6x plus 9. Subtracting x squared from both sides, those will cancel those out. So I'm left with x minus 20 is less than negative 6x plus 9. So let's add 20 to both sides, and let's add 6x to both sides. So I get 7x is less than 29. I can then divide both sides by 7 and get x is less than 29 sevenths. So we have our answer as a simple inequality, but we need our answer to be an interval notation. So I say, okay, the largest x is allowed to be is 29 sevenths. So that means I know that I have 29 sevenths is the largest. I don't want to include it because I don't have an equal. So I have a parenthesis on that side, and I want everything less than that. So I go from minus infinity all the way up to 29 sevenths. The next problem is a similar one. Except this one, we have a couple different things that we have to take into account all at the same time. So we're going to be working on both sides at the same time. So I have negative 4 is less than or equal to 3x plus 5 over 7 is less than 5. We are going to get rid of the ugly fractionness that we have to deal with. So I'm going to start by multiplying all three pieces by 7. So I have negative 4 times 7 less than or equal to, because multiplying by a positive doesn't change directions. I have a 3x plus 5 over 7 times 7 is less than 5 times 7. So I get negative 28 is less than or equal to this times 7 and this 7. Those cancel each other out. So we're left with 3x plus 5, and then is less than 35. I'm going to then subtract 5 from all sides, and I get negative 33 is less than or equal to 3x is less than 30. I can then divide everything by 3, and I get negative 11 is less than or equal to x is less than 10. And then in interval notation, that is going to be starting at 11, going up to 10, and then I don't include 10, but I do include 11. And so that is going to be my answer for this problem. The next problem is a word problem that will take a few steps. So we are buying supplies for a Halloween party. Our budget is up to $72 to buy candy and drinks, every bag of candy costs $12 and every pack of drinks costs $8. We are asked to let X represent the number of bags of candy and Y represent the number of packs of drinks. If each bag of candy is enough to make 5 friends happy, and each pack of drinks is enough to make 3 friends happy, what should you buy to maximize the number of friends that are happy? So first part, what is our objective function? Okay, objective is what are we trying to maximize or minimize? We are trying to maximize the number of friends that are happy. So we are going to let Z give us the number of friends that are happy. So this is our happiness function. So Z is going to be equal to however we can be able to calculate happiness. So we are told a bag of candy makes 5 friends happy. So we have 5 friends are happy times the number of bags of candy. So that's going to be X. So we have 5X. Next, the number of people that are happy based off of drinks is 3. So we also get 3 friends are happy times the number of drinks that we get happy, and that is Y. So our objective function is 5x plus 3y. Part B asks us to write out inequalities for any constraints from the problem. So we have to figure out what sort of things are constraining this. So we go back to our problem and we look for anything that is inequalities. So we have a budget of up to $72. So we are going to have one sort of inequality from our budget. We are told that $72 is our budget. We can't go above that. So that tells us that 72 is greater than or equal to however much we spend on candy and drinks. The amount we spend on candy is $12 times the number of candies that we buy. So that's a 12x. And then the number of drinks is 8 times y. So that's going to give us how much we spend on our drinks. Now, going through the problem, we don't have any other inequalities that show up. However, we do need to remember that x has to be bigger than or equal to 0, and y has to be bigger than or equal to 0. I can't be buying negative numbers of things. So I have all of these different parts to my problem. Part C asks to graph the feasible region from this problem. So we are going to graph the region covered by these inequalities. So this first one, I would rewrite 72 is greater than or equal to 12x plus 8y, just in terms of y, inequality, something, just because that's going to be easier to graph. So we have 72 is greater than or equal to 12x plus 8y. Let's subtract 12x from both sides. So we get 72 minus 12x is greater than or equal to 8y. If I then go from here and I divide everything by 8, I get y is less than or equal to 9 minus 12/8. Now 12/8 can be simplified to be 3/2. So I have y is less than or equal to 9 minus 3/2 x. So I'm going to graph that. So y is equal to 9 when x is 0. So this is the point 0, 9. And then I'm going to go over, so remember this is rise over run. So I go down 3 over 2. So down 3 over 2, down 3 over 2, down 3 over 2. I've gone down a total of 9. That means I will be gone over a total of 6. So I'm able to find that this is the point 6, 0. This could also have been done by setting y equal to 0 in this equation and then solving for x. So I have this line, and I am below this line, bigger than x equals 0. So that is big on this side of the line x equals 0 and above the line y equals 0. So my feasible region is this region here. So now that we have our feasible region, we are able to move on to part D of this problem, which asks, using part C, find the maximum of your objective function from part A, and then answer the question posed in the problem. So let's rewrite our objective function just so that we have it on one page. So we have our objective function is z equals 5x plus 3y. Okay. Now we are asked to find the maximum of this. Now the nice thing about feasible regions is that the maximum always happens at the corner points. So we are going to go and find what are the corners of my region. In finding the line, I found 2 of these points My third point is this one, which is 0, 0. So I'm going to take those points and I'm going to plug them in. So I have the point 0, 0, I have the point 0, 9, and I have the point 6, 0. What we are going to do is we are going to go using this and we're going to plug these in to find what my z is equal to. So here z is equal to 5 times 0 plus 3 times 0, which is 0. This time I have z is equal to 5 times 0 plus 3 times 9, which is 27. And for the last one, I have z is 5 times 6 plus 3 times 0, which is 30. This is my maximum. And so now we go and figure out, okay, I have found the maximum of my objective function and then answer the question posed in the problem. So in the problem, it asks, what should you buy to maximize the number of friends that are happy? That tells us that we should buy, okay, 6, 0. 6 is x. X is the number of bags of candy. And then y is 0. That is the number of drinks. So we should buy 6 bags of candy and 0 drinks to maximize, sorry, you can't see that, to maximize happy friends. And there we go. That's how we are able to do that problem. Moving on to problem 3, we are asked that we are given a function f of x equals 8x to the 7 minus 5x to the 4 plus 6x to the 3 minus 12x plus 8. And we are asked to complete the following parts. So there are 5 parts to this problem. First part is, what is the degree of this function? Well, the degree is the highest power of x that we have. So we have x to the 7, 4, 3, 1, and x to the 0. So this tells us that the degree is 7. How many x-intercepts are possible for a function of this degree? Remember that if you have a function of degree n, there are going to be n possible intercepts. You don't necessarily have to have that many, but you can have up to that many. So that means there are a possibility of 7 x-intercepts for a function of this degree. This particular one probably does not, but you could have 7. Next, how many turning points are possible for a polynomial of this degree? That's how many times can it change direction. It can change direction 1 time less than the number of x-intercepts, or than the degree of the function. So in this case, we have a possibility of 6 turning points. Now, the function as x goes to infinity, we need to look at both the degree and the coefficient of our leading term. So in this case, it is an odd function. So the degree is odd. So we have an odd degree, and we have an even coefficient. So odd degrees do different things in different directions, and the standard one is doing something like that. And we have to figure out, is it doing this or is it going the other way? Is it reflected so it's kind of going that direction? This is for a positive one. This is if it was negative. So we don't have this situation. We instead have this type of stuff. Now in the middle is probably doing a little bit more complicated of a behavior, but at the end point is going to be behaving roughly like this. So this tells us f of x as x goes to infinity, that's going this direction. We are shooting off towards infinity. So we say f of x grows to infinity. And the other direction, as x becomes very negative, f of x itself is also becoming very negative. So here we have f of x drops to minus infinity. And that completes this problem. Okay, this next one is asking us to find domains. So this first one is the square root of 16 minus 5x. And then the second one is the square root of x plus 4 all over x minus 2. So to find domains, we have a couple things that we have to make sure are not happening. So your domain is everything where you don't take the square root of a negative, where you are not dividing by 0, and where you are not taking a logarithm of 0 or a negative number. In this case, we just have square roots and we have division. so we don't have to worry about the logarithms, but that means that we just have to check those things. So this function has as its domain is where we are not taking the square root of a negative number. Or in other words, we need the inside of the square root to be bigger than or equal to 0. So this is where we are saying, okay, I need 16 minus 5x to be greater than or equal to 0. So we can then add 5x to both sides. So we get 16 is greater than or equal to 5x, and then we can divide both sides by 5 to get x is less than or equal to 16/5, which is 3.2. So x is less than or equal to 3.2. That tells us that 3.2 is the largest it can be. We have or equal to, so we have a square bracket, and then it's everything smaller than that, so it's minus infinity to 3.2. For this second one, we have two different things that we need to deal with. First, I need the square root. I can't have the square root of a negative number, so that means I need the inside, the x plus 4, has to be bigger than or equal to 0. Or in other words, I need x to be greater than or equal to negative 4. And I can't divide by 0. That's the other big thing that's a big no-no. I can't divide by 0, so that means I need x minus 2 cannot be equal to 0. Or x cannot be equal to positive 2. So I need this and this to both be true. Now, x bigger than or equal to negative 4, that means I am going to be starting at negative 4. I go all the way up to 2, but then I can't be equal to 2, so I have to say, hey, I'm not including 2. And then I say, oh, and then I pick up again just after 2, and I continue on to infinity. So that's going to be my answer for this problem. For problem 5, we are asked to graph this function. F of x equals x squared minus 3 if x is less than or equal to 1. F of x equals 2 if 1 is less than x is less than 3. And f of x equals 6 minus x if x is greater than or equal to 3. So the first thing, let's graph each one of these things, and we are only going to keep the parts that we actually want to keep. So we are looking at the graph of x squared minus 3. So we'd start graphing that. Say, okay, I know it crosses the y-axis at negative 3. If I plug in 1, I get 1 squared minus 3 is a negative 2. So it's going to be right here. If I plug in negative 1, I also get a minus 2. If I plug in minus 2, I get 4 squared, or 4 minus 3, which is a 1. If I plug in minus 3, I get 9 minus 3, which is 6. So if I go and connect these dots, I'm going to have a function that looks like this. Now, before I continue going on this direction, I am only keeping the part where x is less than or equal to 1. So if I'm covering up everything that I don't include, I am stopping this graph right here at x equals 1. Now I want to include the value at x equals 1, so I'm going to have a dot right here, and I fill it in saying, hey, right here I do want to keep that part. So the rest of my graph is everything here. I'm just shading this a little bit darker so you can see it a little bit better. So that is going to be this first bit, x squared minus 3 when x is less than or equal to 1. If I cover everything else up, it just looks like x squared minus 3. But then bigger than 1, I have to graph something else. Next, I'm saying between x equals 1 and x equals 3, so if we cover everything except that up, we end up with this little slice right here. We want the function to just be the constant 2. That tells us that y is equal to 2 from negative 1 from positive 1 all the way up to 3. But then I have less than, so I don't want to include either endpoint. The way I signify that is I have open endpoints at those two endpoints, and then I just have everything in between is equal to 2. So that's going to be that graph beginning here at 1 and ending here at 3. The last one is 6 minus x when x is bigger than or equal to 3. If I included the entire thing, it would start up here at 6 and it would go over 1, down 1, over 1, down 1, and continue on like that forever. But I don't want to include it here because on this section, I already have defined what my function does. I'm only wanting to look at it on this side. So if I go start at 6, go over 1, down 1, okay, still not in the correct region, over 1, down 1, still not in the correct region, over 1, down 1, I'm at 3, and that is inside my domain. So I can start graphing it at x equals 3. So I'm going to have a solid dot right here. And if I continue, I go over 1, down 1, over 1, down 1, over 1, down 1, over 1, down 1. I continue this line. I get this line right here. And so that's how we're going to be able to go and figure out the rest of this graph. And so this is going to be the graph of that function, f of x equals x squared minus 3 if x is less than or equal to 1, 2 if x is between 1 and 3, and 6 minus x if x is greater than or equal to 3. Okay, this next problem is asking us to look at this problem and figure out linear cost, revenue, and profit functions. So for this one, a company making notebooks has a fixed cost of $132. It costs 75 cents to make a notebook, and then the company then sells the notebooks for 95 cents each. We are asked to let x be the number of notebooks produced. So first, write the linear cost, revenue, and profit functions for this situation. So our cost function, c of x, this is equal to a fixed cost plus some variable cost. So we have a fixed cost of $132 plus however much it costs per notebook times the number of notebooks we make. Well, it costs 75 cents per notebook, and then x is our number of notebooks. So we have plus 75 cents is $0.75 times x. So that gives us our cost function. Our revenue function, r of x, well, this is how much we make per notebook times the number of notebooks we sell. We can sell them for 95 cents each, and we make x of them. So this is a 0.95x. And then your profit function, remember profit is revenue minus cost. So this is going to be my 0.95x minus the 132 plus 0.75x. This negative distributes through everything, so I get 0.95 minus 0.75x. So I get a 0.20x minus 132. And that gives us our profit function. For part B, we are asked to find the total cost and the average cost if the company produces 3,000 notebooks. So our total cost to make 3,000 notebooks is we plug in 3,000 into our cost function. So this is equal to 132 plus 0.75x. Or here, x is 3,000. So we plug 0.75 times 3,000 plus 132 into our calculator. Let me grab mine real quick, and I will do that math for you. Okay, so we put this into our calculator. We have 132 plus 0.75 times 3,000. That gives us $2,382. So our total cost is $2,382. Now, to find our average cost, we are going to divide this by our total that we produced. So our average, or our C bar of 3,000, this is equal to the C of 3,000 divided by our total that we produced, the 3,000. So what we're going to do is we are going to plug this into our calculator. We have 2,382 divided by 3,000. So we divide our answer by 3,000, and we get 0.794. We are asked to round to the nearest cent. So we say on average, it costs $0.79 per notebook, because the extra 4 rounds down. For part C, we are asked how many notebooks do they need to sell to be able to break even. Well, breaking even, that is where you have profit equals 0. So you could say, where is P of X equal to 0? Or, in other words, that is where cost equals revenue. Being able to set either one of these up and then solving for X is going to get your solution. Let's do profit equals 0. So profit is 0.2x minus 132 equals 0. So that tells us that 0.2x equals 132. We can multiply both sides by 5, and we get x equals 660. That tells us that they need to sell 660 notebooks to break even. And the reason for that is because that is the point where profit is equal to 0. Or, in other words, where cost is equal to revenue. Both of those work, and both of those will get you to the 660 notebooks. Okay, this next problem asks us to look at the following situation. So a haunted house finds that when they price their tickets at $11 a person, they get 750 people to attend, and then for every $1 price increase, 30 fewer people attend. What should the tickets be priced at to maximize profit for the haunted house? Okay, so we are going to need to look at the following situation. Remember that profit, that is equal to, okay, so revenue minus cost. In this case, we're like, okay, what do I need to be able to go and figure these different things out? So profit in this case is going to be the price times the number, or I guess in this case, I believe when I put this as the actual problem, it was maximize revenue. So let's go and do that. I'm pretty sure it was originally revenue. I must have printed out an old copy. So revenue, this is equal to price that you're able to charge times the number of people that come. So we're going to, let's let X be the number of $1 increases. So we need to find a price function and a people function. So price, well, if it starts at $11 and then I add X number of $1 price increases, I get $1 times the number of increases gives me my price. So my price function is pretty easy. It's just 11 plus 1x. Now my people function, this is going to be equal to the original number of people minus the 30x, because every time I increase the price, 30 fewer people show up. So I get 750, my initial amount, and then for every increase, I lose 30 people. So this tells me that my revenue function, R of x, is 11 plus x times 750 minus 30x. Now, we are asked to maximize revenue. This is going to become a quadratic, and a maximum is going to happen at the vertex. So we need to rewrite this so that we can be able to find the vertex. So we have two binomials multiplied together. We are going to distribute through, we're going to FOIL, and we're going to write this as a quadratic. So as we do so, let's see, we have our x times x term. So we have that times that gives us a minus 30x squared. We have plus 750x, and we have a minus 330x, and we have a plus 750 times 11. We can put that into our calculator, and we should get 8250, I believe. Let me just double check that real quick. Yes, so that's 7,700 plus 550. That does give you 8250. So once we have this, let's combine terms. So we get a minus 30x squared. This is a plus 420x plus 8250. So your vertex, this is your minus b over 2a. So what we go from here is we can plug in our b and our a. B is 420, so it's a minus 420 divided by 2 times minus 30. So 420 over minus 60. that is equal to 7. So that tells us that our vertex is at x equals 7. So what should the price be? Price is 11 plus 1 times 7. So your price is 11 plus 7 equals $18. Okay, so that's how we would go through and be able to do this problem. Okay, for part B, we are asked, what is the profit that the haunted house makes, or in this case, what is the revenue? What is the revenue that this haunted house makes at that price? Well, our revenue is this function, and x is 7, so we're going to figure out what is r of 7. So that is going to be 11 plus 7 times 750 minus 30 times 7. So that gives us an 18 times 750 minus 30 times 7, 30 times 7. So we have 750 minus 210. So that equals 18 times, that gives us a 540. We can take that, put it into our calculator, see what we get with 18 times 540. It gives us 9,720. So the revenue is $9,720. For this next problem, we are asked to match correlation coefficients to scatter plots. So we have 6 correlation coefficients and we have 6 scatter plots. I had to rearrange them from what you might have seen on the test if you were in my class. So we need to figure out which one of these matches. So remember, the closer it is to either +1 or -1, the closer it is to a solid line. So for our minus 0.96, we are looking for the strongest negative line. So like, okay, this is very weak. This is a positive slope. This one is a negative slope, negative, positive. So we're like, okay, one of these two is our negative. This one is a much stronger negative than this one. So this one is going to be our minus 0.96. Now, we are asked to write in the blank above each scatter plot the correlation coefficient and sketch your best guess for the least squares regression line. We don't need to be super accurate for this. Our best guess is a line that roughly matches this, so that would be my line. Okay, so I've gotten this first one, check. My next one is minus 0.64. So I'm now looking for the next strongest negative slope line. My only other one that I'm like, yes, that's definitely a negative sloped line is this one. So that line is going to be roughly like this. This is going to be my minus 0.64. Okay, might as well draw the lines for these ones while we are here. We draw our lines, this one, this one, this one. That looks like there's not really a correlation. It's going to be pretty much flat. So it's going to probably be something like that. Sorry for that. What we can do here is now we can be able to look to see, okay, which one of these is closest to minus 0.08? Which one of these basically has no relation? So we were like, okay, very strong, sort of strong, like still positive, definitely not negative. This one has practically no correlation. So that's going to be our minus 0.08. And then we have 3 positive ones. So let's start from the strongest to the weakest. So our strongest of 0.92, this is definitely this one. It is definitely the strongest of those lines. So this is our positive 0.92. Our next weakest, or our next strongest, sorry, is our 0.75. This one looks a little stronger than this one. So I would say that this is the 0.75, and that leaves this one as our 0.51. All of them are positive sloped lines. We're just ranking them according to how strong they are. So that completes this problem. Okay, for this one, we're in the situation where the Baylor physics department is shooting pumpkins from a cannon, and then they are measuring the distance each pumpkin traveled compared to their weight. So the data that they collected is given on this scatter plot. along with the least squares regression line. So y equals minus 2.53x plus 77.21. So first off, is the data positive or negatively correlated? Okay, is in a negatively sloped line. So our answer for that is it is negative. Okay. Part B says if we stick our 7 kilogram jack-o'-lantern into the cannon, how far do we expect it to fly? Okay, if we're looking at how far do we expect something to fly, that is going to be our prediction from our least squares regression line. So we come up here and we're like, okay, I have this line. What am I predicting if I plug in x, my weight of 7? So if I come up here, I'm figuring out what point is that right there on that line. It's too close to be able to estimate it based off of just the graph. So I'm going to have to actually calculate this. So I'm going to plug in into minus 2.53x, in this case that's 7, plus the 77.21. So I'm going to take that and I'm going to plug that into my calculator, and I'm going to be able to see what I get. So I have minus 2.53. Oops, I had something in my calculator still there, so let's fix that. Okay, minus 2.53 times 7 plus 77.21, and that is equal to 59.5. So our answer is how far do we expect it to fly? Don't forget your units. Our units are in meters. So we would expect it to fly 59.5 meters. Now, for part C, for every additional kilogram the pumpkin weighs, how many meters more or less does the pumpkin travel? Be sure to specify more or less. Okay, we plug in different things here. This is telling us how much more or less it's changing. So for every 1 I change here, my slope tells me how much it changes. So it is going to travel exactly my slope, which in this case is negative. So that tells me it's going to go 2.53 meters less distance. And there we go. Okay, for this next problem, we are given f of x equals x squared plus 8x plus 12, and we are asked to find the following. If any of these don't exist, we need to state why they don't exist, or they don't exist and why. So first, the domain. Okay, remember, domain is where you either have a logarithm of 0 or negative. That doesn't happen in this problem. We have a square root or any other even root of a negative. Again, that's not happening in this problem. Or we divide by 0. We might have that in this case, so we need to say, okay, I need where 2x squared minus 6x minus 20, that cannot be equal to 0. So if I go through and rewrite this, I can factor out a 2 from everything. So that's a 2 times x squared minus 3x minus 10. That is not equal to 0. Where is this not equal to 0? Well, that's where if I factor this, both pieces can't be 0. So if I factor this, that becomes an x minus 5 times x plus 2. If you don't see that, you could also use the quadratic formula to be able to find these 2 points. So those are not equal to 0. So this tells us that x cannot be 5 because we can't have this first piece become 0. And we also have x cannot be negative 2 because I need this piece to not be 0. So in interval notation, it's minus infinity to minus 2, together with minus 2 to 5, together with 5 to infinity. Okay, for part B, what are the x-intercepts? Okay, this is where, in a rational function, this is where your top equals 0. So we are solving for where is x squared plus 8x plus 12, where is that equal to 0? Well, again, we could either factor this or you could use your quadratic formula. I'm going to factor this. It factors as x plus 2 times x plus 6. So that is equal to 0 at either x equals minus 2 from this first piece, or from the second piece, x equals minus 6. Now, this is where it's important to check something. We are only able to have x-intercepts in our domain. So first, is x equals minus 2 in our domain? It is not. That is specifically one point where it's not in our domain. So this is not in the domain. So our only answer is x equals minus 6. So an x-intercept of x equals minus 6, 0. To find our y-intercept, this is where you plug in 0. So f of 0 equals 0 squared plus 8 times 0 plus 12 divided by 2 times 0 squared minus 6 times 0 minus 20. That's 12 over minus 20. If we simplify that, that is 6 over minus 10, or a negative 3/5. So this tells us that we have a y-intercept of 0, negative 3/5, or 0 and negative 0.6. Okay, for D, the vertical asymptotes of f of x. Okay, this is where your bottom equals 0 and specifically where the top is not equal to 0. Well, in our domain, we already found the places where the bottom can be 0. The bottom can be equal to 0 at x equals 5 and x equals negative 2. But the top is equal to 0. So we also need x cannot be negative 2 and x cannot be negative 6 because we already found where the top is equal to 0. So we need x to be equal to negative 2 and not equal to negative 2. Okay, that just tells us that those are not even possible. So our only x-intercept, or our only vertical asymptote, sorry, is x equals 5. The other one, because the top and bottom are both 0, that is actually going to be a hole. So this one is actually a hole. So that is why that is not going to be a vertical asymptote. Lastly, the horizontal asymptote of f of x, that is what happens as x gets really, really big. So remember, horizontal asymptotes only matter based off of the highest coefficient, or the coefficient of our highest degree terms. So in this case, we only care about the x squared and x squared terms. So we have x squared plus a whole bunch of stuff divided by 2x squared minus a whole bunch of stuff. So we have something like this, or this x squared, that's really just 1x squared. And to find your horizontal asymptote, you only look at the fraction ratio of your leading coefficients. So this is a y equals 1/2 is going to be your horizontal asymptote. And that completes this problem. For this problem, we are asked to look at this graph and figure out intervals of increase, decrease, concave up, concave down, your x coordinates of any maximums and minimums, and any x coordinates of inflection points. So increasing, we say, well, where is this function going up? Well, it's going up everywhere over here, and it's also going up over here. So we say it's going to start increasing at minus infinity, and it continues to increase up until right here. That is the point where it stops increasing, and that is at x equals 1. Or sorry, x equals minus 1. So it's increasing there, and then it increases again. So we write this little u for union. It starts increasing again right here at x equals positive 1, and it continues increasing forever. So it increases on this interval. Where is this function decreasing? Well, it's decreasing from here to here, so it's decreasing from minus 1 to 1. And remember, we use parentheses on all of these because we are not increasing or decreasing at the endpoints. Those are places where it is constant. Okay, next we are asked, where is this function concave up? So remember, concave up, that is where it's making like a smiley face. Well, it is going to be concave up from here onward. So it's going to be concave up from 0 to infinity. Next, we are asked concave down. That's like a frown. Well, it's concave down on this section right here. So it's going to be concave down from minus, forgot parenthesis. It's concave down from minus infinity up to 0. Okay. We are now asked to find our places where we have relative maximums and relative minimums. So we have a relative max right here. We have a vertex-ish thing right there. So that's at x equals minus 1. We have a relative minimum right here at this little valley, that's at x equals +1. And then inflection points. This is where it changes concavity. So the only spot it changes concavity is at x equals 0. So right here, so we have a inflection point at x equals 0. Okay, this last problem is an exponential growth type problem. So the number of ghosts at Hogwarts on Halloween grows exponentially during the day. At 9 a.m., there are 8 ghosts, and at noon, there are 24 ghosts. For part A, find a function modeling the number of ghosts in Hogwarts at time t, where t equals 0 corresponds to 9 a.m., and t is a number of hours, of the form f of t equals y0 times b to the t. We are asked to round b to 5 decimal places. So in this case, we are told 2 pieces of information. At 9 a.m., which is t equals 0, there are 8 ghosts, and at noon, so that's at 12 o'clock, so 3 hours later, so this is at t equals 3, there are 24 ghosts. So that tells me that f of 0 is 8, and f of 3 is 24. So f of 0, I can plug that in here. So this is the same thing as y0 times b to the 0, and this is y0 times b to the 3. Well, b to the 0 is just 1. So this is y0 times 1, which is y0. So this tells me that y0 is equal to 8. So that's a helpful piece of information. I can take that and I can plug it into this, and I get 24 equals 8 times b cubed. I can divide both sides by 8, and I get 3 equals b cubed. So that tells me that b is 3 to the 1/3. So I can take that, put it into my calculator, and I can see what I get. So I get 3 raised to the 1/3 power, or the cube root of 3. And I get b equals 1.4422, and then it's 49. I need 5 decimal places, so I round the 49 to a 5. So this tells me that my function is going to be f of t equals 8 times 1.44225 raised to the t. Now the last part of this problem, part B, find out how many ghosts there will be in Hogwarts at midnight. Okay, so midnight, this is 15 hours after 9 a.m. So this is equal to t equals 15. So we are going to plug t equals 15 into our function. So we are figuring out what is f of 15. So this is 8 times 1.44225 raised to the 15. So we can take that, put that into our calculator. We say, what is 8 times 1.44225 raised to the 15? And our answer is, this is 1,944.00868. Okay, we're asked to round to the nearest ghost, so that we are going to round to the 1944. And so our answer is that there will be 1,944 ghosts at midnight. And there we go. That is how you are able to go through and solve any of these problems. If you're in my class, feel free to come and ask me more in my office hours. And if you're not, feel free to leave it in the comment section down below. I hope you have a great rest of your day, and good luck with all of your math.